Hey everyone, welcome back to another video. Welcome back. We're back. Don't worry guys. I just had to take a 1 day break because I was going through some mental stuff. It's just that making videos like this are not easy because you have to make 50 minutes. It's hard, mental exhaustion, etc. But don't I just made time. I just relax my mind, just take a break and free. Okay. But I will talk about something. In my last video on the argument, everything is correct except the last thing in the last part where I forgot to put 2πk at the end. But whatever, that's just a small mistake. But the main thing I'm going to talk about is if in the exam, if your teacher wants to put the argument in radians or degrees, for that I would recommend using a calculator, scientific ones or some other ones which are good calculators recommended by the school. However, if not, just let me know in the description, in the comment section, okay? Or my Discord server if you join it, okay? Because I will make a video. I'll show you some some trigonometric functions, okay? And whose value of theta will give a certain angle, so it'll be helpful to remember, okay? But in today's video, we are going to be proving the modulus, yeah. So my last video we covered the topic of argument. So now we're gonna cover the modulus. Okay. So I felt that when I was making a series on complex numbers, I knew that I was making a video proving the modulus formula, but I also felt that I should also show a representation of it to explain it better. So let's see. So I'm not gonna draw the whole thing out, okay, because it's kind of overwhelming. But here's the idea: just take any complex number. The quadrant won't matter in this case, okay. So suppose I take a complex number. Let's say I take a complex number 3 plus 4i, okay. So 3 steps here, 1, 2, 3, okay, and 1, 2, 3, 4. So let's call this point. Let's call this point 3, 4. Okay, and this point represents the complex number 3 plus 4i. All good? Okay. Yeah. So this point, this would be 3. No. Hold on. What did I do? I think I did 3 either. So it's supposed to be, yeah. So 3. So 4 steps here. 1, 2, 3, 4. And 1, 2, 3. Okay? And then when we make this point, we get something like this. 3, 4. Okay? And this point right here, this would be something like 4. And this would be yeah. And this would be 4i. And this would be 3. Okay, yeah, sorry. I'm sorry for the confusion. My mind is kind of exploding. But anyways, we have 2 points, right? 3 plus 4i, which makes the points A, B, 3, 4. Okay? So now we have this complex number, 3 plus 4i. Here's what I'm gonna do. I actually make some space. That's fine. Okay, so if I have the points here, 4i and 3. So what I want to do is, let me put this bottom. Yeah. So I want to join these points. Okay. Now this is called the geometric representation of a complex number. We're gonna draw some lines. Here. We're gonna draw some lines here. Okay. And connecting the real point to the dot, and same with the imaginary section. Okay. So like this. So now that we connect these 2 points, the imaginary side, and the number of line depends. The number of lines is not important. It's just that you know how to connect them. Okay. So as you connect these, now we're gonna use the same concept as the argument. Okay. All right. So what we're gonna do is, I'm just gonna draw a right angle triangle right here. And in this case, the hypotenuse right here this is the modulus. The reason is that because this is the hypotenuse, and when we use let me show you. When we have a right angle triangle, we have C, and these are other legs AB. So the Pythagorean theorem says that a squared plus b squared is equal to c squared. Now look, what if you do something? If you want to, the goal here is to find c. And what is c? C is the hypotenuse, okay? So if you want to find c, what do you do? You have the opposite answer. Opposite answer is you take the square root of both sides. And when we do that, we'll just get c alone by itself. So c would be equal to the square root of a squared plus b squared. And this exact formula is the exact formula we use to calculate the magnitude of complex numbers, or the distance, okay? So this line right here is the hypotenuse. Alright? So now I'm going to show how this connects to the distance between 2 points formula, okay? So now the distance between 2 points formula would be, look. Okay, look. So then we have 2 points. Okay. The distance between the 2 points would be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. And this formula is to find distance between points, okay, between the points x2, the points x2, y2, and x1, y1. So this is the formula which is often familiar to us. Okay? So the same way, we could think of this like in the same concept here. Now what we're doing is, we're essentially finding the distance from here. Now this is the origin, okay? This is the origin. And this represents the point 0, 0. Because this represents the complex number 0 plus 0 I, right? So what we're doing is, we're finding distance between 2 points, distance between points between 3, 4 and 0, 0. Okay, that's what's going on here. So what's happening is, there's 2 connections. The first connection is the Pythagorean theorem, the right angle triangle, and the second relation is this formula, the distance between 2 points formula. And I'm going to show how the distance formula and the Pythagorean theorem relate to each other, okay? And note that if we plug this in, so if you find the distance, let's find the distance, okay? So if you have to find the distance, what would the distance be? The distance right here would be points, the square root of x2 minus x1. So look, in this case, this is x2, this is y2, this is x1, this is y1. So the formula would be, okay, it would be x2, which is 3, minus x1, which is 0, squared, plus y2, 4, minus y1, 0 squared. Okay? Now with this, we get the square root of 3 squared plus 4 squared, which is in the form AB. This is A, this is B. And when we simplify this, we get something like Yeah, 3 squared plus 4 squared will be the square root of 5 squared. And 9 plus 16, 25. So this would be the square root of 25. Which is equal to 5. So this right there will be equal to 5. Okay? Alright, so now that we've done this, now I'm going to show the relation of the Pythagorean theorem and the distance between the 2-point formula and the connection. Let's show the connection, okay? Okay, everyone, I made some space now. Now, we're going to figure out the relation. So look, you can see something similar, right? So first, I'm going to show the formula side by side here. Let's understand this first. So in the Pythagorean theorem, if you have a right angle triangle right here, okay, this is A, this is C, the hypotenuse, this is the hypotenuse, okay, which is the same case here. This is the hypotenuse and the complex plane of the complex number with the points, and this is A, this is the first leg, this is the second leg, okay. So now, we can see that C is equal to the square root of A squared plus B squared. Okay, we know that now. We know that the modulus of the complex number A plus BI will be the square root of A squared plus B squared. We know this, but now we're going to prove it, okay? And yes, we can find the modulus of a complex number in any quadrant. It doesn't matter, okay? Because it's not like the argument. It's like just generally find the distance. Like the sign doesn't matter. We just find the distance, okay? So now we have this. C is equal to the square root of A squared plus B squared. Now look at the distance between 2 points formula. It would be to find the distance between 2 points x2 y2 and x1 y1. We give the square root of x2 minus y2 squared plus x1 minus y1 squared. And something is familiar, right? This is in the same form. There's a radical, okay? There's also a square, and so this is like almost like saying A. This is almost like saying that A is equal to x2 minus y2, and B is equal to x1 minus y1. And if you're taking this, you're absolutely correct. Good job. Now, but the thing is, you're gonna have to put an absolute value here. Why? Because we don't want the sign to be negative. That's why we're putting our absolute value. Now, we can generate the same triangle again, okay? So when we generate the same triangle, suppose I make a right angle triangle right here. Okay? So think of this as the A. The modulus of x2 minus y2, okay? And the modulus of x1 minus y1. And this is the C, which is, and this is the C, which is the modulus of the complex number, which we have to find, okay, in this case. So look, so now we know that this is the connection. This is the connection to the distance between 2 points formula and the Pythagorean theorem and the right angle triangle. Now look carefully. We're putting modulus because the sign shouldn't be negative, it should be positive, like always. Now, the reason you might be thinking, why are we subtracting? Well, it's a simple reason. When you're finding the magnitude, the distance, we also subtract that. For example, let me give you an example. Suppose, suppose you find the absolute value of suppose we're finding the distance. Okay, look. Suppose we're finding the distance between. So distance between 7 and 3. So when we find the distance, you have to subtract. That's the logic here. When you find the distance between two numbers, or in this case we have points, we're going to subtract them. We'll get 4. Yeah, so that's how it basically works. Okay. That's why I'm subtracting it. And yeah. yeah, we should, and that's why we gotta put a modulus here. Because when you're finding the distance between two numbers, look, when we're finding, like, it's common logic. We're putting the modulus here because suppose if I say 7, the distance between 7 and 3 is 4. That makes sense. But if I find the distance between 3 and 7, I'm gonna subtract them also. So it'll be 3 minus 7. The modulus of that. But I'm putting modulus because it wouldn't make sense to say that 3 is minus 4 units away from 7 because it just doesn't make sense, right? We can only measure the distance with a positive number. So that's why we're doing that. And that's why when we find the distance between two complex numbers, we always use, that's why we have the modulus. Yeah, that's why, this is why we use this for distance, okay? Particularly this is for 0. The distance between 0. Okay. So now that that's clear, yeah. Like when we're finding distance between 2 points, x2, y2, and x1, y1, just think of this generally. When you're finding how far, distance means how far, okay? How far. So this means we have to find how far is this point from this point. Now we have to use the same logic. Like if I say how far is 7 from 3, we'll say 4. Exactly, the same way. When we're finding how far 2 points are from each other, we are going to subtract. Good? That's why we get this. That's why we get, but see, look, well, because we're subtracting this and this, okay, and we're subtracting this and this. So when we're finding the distance between x2, y2, x1 minus y1, we're subtracting y2, y1, x1 and x1 because these are corresponding. Okay, the difference is they're 2D. So like, if I have x2, y2, and I have x1, y1, so just to make it final, okay, what is this? Yeah, x1, y1. So what I'm doing is, the distance between these 2 points would be the modulus of x2 minus x1. Okay? x2 minus, no. What's your name it? Sorry, I think it should be, yeah, it should be x1. Oh, sorry. x1. Yeah. Okay, what am I doing? y1, y2. Okay, wait. Yes. Yes, back to the point. Where was I? Yeah. This is how it should be. The distance between 2 points respectively. This and that. And y to y1. We have to subtract x2 from y2. Okay. And we have to add x1 minus y1. The reason we're adding is because we already subtracted these 2 points. We subtracted these 2. Because it's not like we can find it, the distance from this, not from just 0, we can find it from any point. Because the modulus symbol is used to find distance from 0, but the distance between 2 points, we can find distance between any 2 points. So we're adding those. Okay. Because, and that's why, you know that we can write this as x2 minus y2 squared of the square root of x1 minus y1 squared. Makes sense. No wait. I think that. No wait. I think that when we're finding the distance between these 2 points, y2 and 1, it should be the whole modulus x2 minus y2 plus, yeah, minus y2 plus x1 minus y1. Okay? And we can rewrite this as the square root of x2 minus y2 plus x1 minus y1 squared. That's how they're related. Because we know that the absolute value of x is equal to the square root of that number squared. If we didn't know that. So that's how we just rewrite this formula like this. The distance between 2 points on it. We rewrite it like this. Okay? Hold on, I have no battery. Okay. And we're adding this because we already subtracted these two. It makes sense though. And I'll show you why it makes sense. And the reason why we're adding is because in order to find out why we're adding this, we're going to go back to the triangle. So as we discussed, we put the modulus here. Just have to explain to find the distance between 2 points, but just also we have to subtract the 2 numbers which are corresponding here and here. Now that we have this, A, B, and C. So if C is equal to the square root of A squared plus B squared, which we derived, then this should be the square root of this square minus, which should be plus. Yeah, that's why it's plus. Because, okay, let me get space. We just erase this. So, yes, that's why we're adding it. That's why we're adding it basically. Because in this case, I told you why we subtract when we're finding the distance between 2 points. But now we're going to get to this plus sign in the middle. Why we're adding it, okay? So now coming back to the triangle we had earlier, this one. This is x2 minus y2, and this is x1 minus y1. This is A, and this is B. So this is A, this is B, and this is C. So what happens is, C, this modulus is equal to the square root of x2 minus y2 squared plus x1 minus y1 squared. This is the relation. This thing right here. This is the relation. Because when we're finding a side, when we're finding the hypotenuse in a right angle triangle, we have to, it's the square root of a squared plus b squared, not minus, because sideless cannot be negative, and the length cannot be negative as well. So that's why we put the modulus, because when we find the distance between 2 points, something that's negative, and so we have to put modulus, okay? So then which are positive, like the distance between 3 and 7, we can't subtract them. We have to put the modulus, and then we'll get 4, because we can't set 3 is negative 4 units away from 7, okay? That's the recap, okay? Just a brief recap. Now you get this. And you have to, how do you simplify this? Let me show you. Right here, have the square root of the square root of x2 minus y2 squared, and this whole thing is squared. So this a square is squared. Looks pretty big. But don't worry, we're gonna add the square root of x1 minus y1 square, and then we square this whole thing again. Okay? So this is the whole expression we get. So what we're doing is, we're taking the square root, okay, let me just write simpler here. So c is equal to the square root of x2 minus y2 raised to the power 4 plus the square root of x2 minus y2 raised to the power 4. And the reason we get 4 is because in this case, we open the modulus value, we can write this as the square root of x2 minus y2 squared, and we're squaring the whole thing as well. Because, yeah, and then we square this thing. Because we can write this modulus as this, and we can rewrite this as this. And we're squaring the whole thing, so it becomes to the power of 4, if we multiply the exponents. Okay? Alright, now we get now, if you simplify this, we get the square root of, okay, so 1/2 raised to the power of 4, which would be x2 minus y2 squared plus it should be 1, yeah, plus x1 minus y1 squared. And bam, look, we derived this whole formula that we have got in the beginning. Pretty cool, right? It's very cool. Yeah, no. This is the original formula to find the distance between 2 points, x1, x2, x1, and y2, y1. The distance between 2 points, x2, y2, between x2, y2, and x2, x1, and y2, y1. If you want to find the distance between them, we'll use this formula: the square root of x2 minus y2 squared plus x2, x1 minus y1 squared. And look at this, guys. We have got the same formula we derived by doing all this work from the Pythagorean Theorem, which is very cool, actually. Right angle triangles are very cool. And yeah, that's the cool beauty of math. And so that's how we get the modulus of a plus bi, the square root of a squared plus b squared. It's very cool. Yeah, it's very cool, actually. So if you want, you can rewatch the video, just understand the clear topics, okay? Just go through it slowly, it'll take time, but yeah. So that's how it happens. So yeah, that's how we got all this work from the Pythagorean Theorem. Okay? And we got to write modulus. So yeah, we ended up from this to this. We derived the whole formula. And that's why this is the distance between 2 points x2, x1, y2, y1. Okay, so that's a quick recap. And that's why the absolute value of a complex number is the square root of a squared plus b squared. Because it relates to this. Because we can represent the points of a complex number like this. In this case, 3, 4, and 0, 0. Okay? Alright, it's all good. Yeah, I'm clear some space now. I hope you enjoyed the video now. I'm not gonna make it too long now. This should be enough. And the reason we can't count manually to find the distance of a complex number from 0 because they're 2-dimensional. However, when we find the absolute value of a real number, we just count. Like the absolute value of 5 is 5. And imaginary numbers are also 1-dimensional. So the absolute value of 5i will just be 5. Like if you have a number line, suppose you have a number line. You have a number line, okay? Imaginary number line. So this is 0i, this is 1i, 2i, 3i, 4i, 5i. The distance right here would be 5. Just like counting. Because they're 1-dimensional, we can count manually. But complex numbers are 2-dimensional. So that's why you have to use this whole formula. But it's pretty cool. Yeah, so math is really cool. Very cool. Okay? So I hope you enjoyed today's video. If you want more, just hit the like button. And yeah, we will see you guys in the next video. Okay? The beauty of math. Right? So yeah, this is how to find the absolute value. I think I don't have time for polar form. I'll do polar form in the next video. Okay? For now, I hope you enjoyed this video. It's very interesting. Alright? And if you have any questions still, you can let me know in the comment section. Okay? I think that should be about it. We'll wrap up today's video. So I hope you enjoyed today's video. Just want to put on the whiteboard now. Alright, okay, so quick recap of what we learned. So we learned the distance between 2 points formula. We derived it by the Pythagorean Theorm, okay, by explaining how distance between 2 points is also related to the difference of some like if you have x2, like if you have x2, y2, x2, x1, and y2, y1. In order to find the distance between these are 2D, not 1D. So we have to just subtract this. This is how we find the distance between 7 and 3. We subtract them to get 4. Okay, and yes, the distance between 3 minus 7 will be 4 as well by taking the modulus, as I explained. So we have to subtract this, and we get the whole modulus thing. We have to take the modulus because length cannot be negative, because distance cannot be negative. Then that's why we put the whole modulus in, okay? So we have to subtract this. We have to subtract this while putting the modulus. Okay, these two things. I'll put in the modulus, subtract these two things. I'll put in the modulus and then add them. So that's how we get the square root of x2 minus y2 squared plus x1 minus y1 squared. Triple right? Y2, y1. Alright guys, so I hope you enjoyed today's video. That should be all. And this is just a brief recap. To find the whole summary, you have to watch the whole video to understand the full explanation. Alright guys, so I hope you enjoyed this today's video. Bye-bye. Bye-bye.